Welcome to the Walton Pi. Today we are talking about inverse relations and inverse functions. So to start off, let's define what an inverse relation is. So if R is a relation from A to B, then the inverse relation is R minus 1, just the notation, from B to A, given by the relation R minus 1 is equal to the set of pairs B comma A, where the pair A comma B was in the relation R. If this inverse relation is a function, then it is called an inverse relation. So this begins our collection of theorems involving inverse functions. So the main theorem is that if f is a function from A to B and g is the inverse relation of f, g is a function from B to A if and only if B was a bijection. So let's start by proving the forward direction. Assume that g is a function, and that tells us that every element in B maps to some unique element in A under g, meaning that g is well defined. Thus, every element in B was mapped to by exactly one element in A by f, so that tells us that f is a bijection from A to B. The reverse direction, we start by assuming that f was a bijection. Then that means that every element in B was mapped to by some unique element in A under the function f. That tells us that g then maps each element in B to exactly one element in A, so that tells us that g is a function from B to A. We now have four smaller theorems, all involving inverse functions and relations. So, if f is any relation from A to B, then f inverse inverse is going to just be f. The proof of this just relies on the fact that the inverse is reversing the ordering on pairs. So if we reverse the order twice, the pair being AB, reversing once becomes BA, reversing a second time becomes AB again, that tells us that every pair will return to how it was originally. So f inverse inverse is always equal to f. The second theorem involving inverse relations is that if f from A to B is a bijective function, then f inverse from B to A is also going to be a bijection. To prove this, we start by saying that if f is a bijection, then we know that f inverse is a function from B to A, as a result of the very first theorem we proved before we started these smaller theorems. From theorem 1, which we have right here, we know that the inverse of f inverse is just f. So that tells us that the inverse relation of f inverse is also a function, which means that going back to our very first theorem of the video, f inverse is going to be a bijection. The third smaller theorem involving inverse functions is this one. If f is a function from A to B and it is bijective, then f inverse of f is the identity function on A. So to prove this, we first start by showing or noting that f inverse of f and the identity function on A are both functions from A to A. That means we only need to show that f inverse of f of A is equal to A for all the elements A in our set A. So, for any little a, we note that the pair A comma f of A is a pair in our function f. So that means that f of A comma A is a pair in f inverse. So, f inverse of f is going to go from A to f of A back to A. So we have shown that f inverse of f is the identity function on A. The fourth theorem is almost the exact same, except it is f of f inverse is going to be the identity function on B. Pretty much all of the argument stays the same, except we are switching the roles of f and f inverse. But we are able to successfully show that f of f inverse will be the identity function on the codomain of f, B. Thank you for watching. Hopefully this video was helpful. Please check out some of my other videos and like and subscribe, because that helps me out quite a bit to be able to continue to make these videos to explain different concepts of mathematics. Hope you have a wonderful rest of your day, and good luck with all of your other math.